For today's session, we're going to have the laws of logarithm. Let's do have the basic concepts on the laws of logarithms, so the properties of logarithms. So it states there that let b be a positive number not equal to 1. Let x and y be any positive number and n be any real number. So actually, there are three particular laws or properties in logarithm. The first one is the law 1 or the logarithm of a product. So the formula or the pattern that we are going to follow in the first law of logarithm is logarithm of xy base b is equal to logarithm of x base b plus logarithm of y base b. The only thing that you need to remember in the first law is every time that you are going to multiply two particular positive numbers and then you are going to relate it to a logarithmic expression, we tend to add them as the result. So again, the logarithm of xy base b is equal to logarithm of x base b plus logarithm of y base b. That is the first law of logarithm. So the second law of logarithm, we call it as the logarithm of a quotient. So this time, the mere fact that we mentioned about the quotient, we tend to divide two particular positive numbers. So the pattern that we're going to follow in the second law of logarithm is logarithm of x over y base b. So every time that you are going to divide two particular numbers and then we are trying to relate it to logarithmic expression, the end product or the result is always logarithm of x base b minus logarithm of y base b. So the only logic that we need to remember in the second law of logarithm is that every time that you are going to divide two particular positive numbers and then we are going to correlate it to a logarithmic expression, we tend to get the difference of the numerator and then the denominator. But then this is correlated with the logarithmic expression. So in short, the logarithm of x over y base b is equal to logarithm of x base b, that's the numerator, this one, minus logarithm of y base b, that is our denominator. That is the second law of logarithm. Now, the last law of logarithm, we call it as the logarithm of a power. Now, the logarithm of a power is just very simple. So, the logarithm of x raised to n base b, the result of this one is that you will just write the power or the exponent before the logarithmic expression. So, as you can see, we just simply write n here, and then we write logarithm of x base b. So these are the three particular laws that we need to remember in the laws of logarithm or the properties of logarithm. Okay, so let's do have some examples. The instruction is use the laws of logarithms to expand each term. Let's do have the example number 1. Example number 1 states there that logarithm of 8x base 3. So we are going to expand this one using the properties of logarithms that we discussed a while ago in the preceding slide. Now, the logarithm of 8x base 3, if you are going to check this one, the number, this one, it is simply multiplying 8 with x. It's actually a monomial. So, logarithm of 8x base 3, the law or the property that we are going to use this one to expand the given in number 1 is the law 1. Using the law 1, or the first law of logarithm, which is the logarithm of a product, it states there that logarithm of xy, x and y here are any positive numbers. Logarithm of xy base b, the expanded form of this one is logarithm of x base b plus logarithm of y base b. So if we are going to apply this particular pattern in our given, which is logarithm of 8x base 3, the expanded form of this particular given will be logarithm of 8x base 3 is equal to logarithm of 8 base 3 plus logarithm of x base 3. So we just simply follow the pattern. How did we come up with law 1 as the rule that we are going to follow in getting the expanded form of logarithm of 8x base 3? Because if you will try to check again the number involved in the example number 1, 8x is simply a product of 8 and x. So this prompted us, this will be our clue that we are going to use the first law of logarithm, which is actually the logarithm of a product. Therefore, the expanded form of logarithm of 8x base 3 is equal to logarithm of 8 base 3 plus logarithm of x base 3. Let's do have example number 2. Example number 2 is logarithm of quantity 11 over x base 5. So we are asked to get the expanded form of this particular logarithmic expression. Now, if you will try to check, the number involved or the n involved in example number 2 is actually getting the quotient of 11 and x. So 11 over x or 11 divided by x. In that case, we are going to utilize the second law of logarithm, which is the logarithm of a quotient. It is given by logarithm of x over y base b is equal to logarithm of x base b minus logarithm of y base b. We actually get the difference of their denominator, the numerator and then the denominator. So if we will try to apply the second law of logarithm in number 2 to get the expanded form, we will have logarithm of quantity 11 over x base 5 is equal to logarithm of 11 base 5 minus, because we are actually dividing two particular terms, minus logarithm of x base 5. Therefore, the expanded form of the logarithm of 11 over x base 5 is equal to logarithm of 11 base 5 minus logarithm of x base 5. Let us continue with our example number 3. Same instruction. Use the laws of logarithms to expand each term. So our given here is logarithm of x cube root of y base b. So if you will try to check this example, we can actually write this one as logarithm of x y raised to 1/3 base b. Why? Because cube root of y, if we are going to remember your grade 9 mathematics, cube root of y, we can convert it into exponential form, having a rational exponent. Okay? So logarithm of xy raised to 1/3 base b. So we are going now to use this one in getting the expanded form. Now, if you will try to check logarithm of xy raised to 1/3 base b, these two particular numbers, you are actually multiplying x with y raised to 1/3. The mere fact that we are multiplying xy raised to 1/3 and it's actually correlated with a logarithmic expression, it's actually a manifestation of product rule in logarithms, so the product law in logarithms. So using the law 1, which states here that logarithm of xy base b is always equal to the logarithm of x base b plus logarithm of y base b. I forgot to say a while ago that this expression on the left side, we call this one as the condensed form of logarithm or the single form of the logarithm. And this expression on the right side, we actually call it as the expanded form of the logarithm. So applying this one here, we will have logarithm of xy raised to 1/3 base b, that is equal to logarithm of x base b plus logarithm of y raised to 1/3 base b. But if you will try to check, we still have another logarithm to use in order to get the full expanded form of this logarithm. Now, if you will try to check, this one is actually a manifestation or an application of the third law of logarithm, which states here that the power rule or the logarithm of a power states there that logarithm of x raised to n base b is always equal to the power or n logarithm of x base b. So we actually write the exponent or the power before the logarithmic expression or the logarithmic term. So if we will try to apply the law 3 here, specifically in this particular part, the final answer would be logarithm of xy raised to 1/3 base b is equal to logarithm of x base b plus 1/3. We just actually write 1/3 before logarithm of y base b. Therefore, the full expanded form of logarithm of x cube root of y base b is equal to logarithm of x base b plus 1/3 logarithm of y base b. So that is our example number 3. Now let's do have another set of examples, but this time we will reverse everything. We will reverse what we did a while ago. So a while ago, what we did is we will get the expanded form of logarithm. So from the single form, we are going to get the expanded form. This time, we are going to express the following logarithms as a single logarithm. So from the expanded form, we are going to get its single form or the condensed form of logarithm. So the first example is logarithm of 3 base 3 plus logarithm of 27 base 3. Now the operation involved in these two particular logarithms is addition. The mere fact that we are adding two particular logarithms, this is actually a result of multiplying two numbers or two particular expressions in logarithm. So in this case, we are going to use the first law of logarithm, which is the product law of logarithm. Logarithm of xy base b, that is equal to logarithm of x base b plus logarithm of y base b. So the only logic on what we are going to do in this example is from the expanded form, we are going to return this one, or we are going to express this one as or in single form. So in this case, since logarithm of 3 base 3 plus logarithm of 27 base 3, we are adding two particular logarithms. This is actually a result of getting the product of two numbers in logarithm. So having said that, the single form of logarithm of 3 base 3 plus logarithm of 27 base 3 is equal to logarithm of 3 times 27 base 3. Simplifying this further, you will have logarithm of 3 base 3 plus logarithm of 27 base 3 is equal to, this will be the single form, logarithm of 81 base 3. So that is our first example. Let's do have the second example. Logarithm of 5x plus 4, or logarithm of quantity 5x plus 4 minus logarithm of x. So in this case, if you will try to check our example number 2, we are actually getting the difference of two particular logarithms or two particular logarithmic terms. So the mere fact that we are getting the difference of two particular logarithmic terms is actually a result of getting the quotient of two particular numbers or terms in logarithm. So we are going to use the second law of logarithm here, or the quotient rule in logarithm. So which states there that logarithm of x over y base b is equal to logarithm of x base b minus logarithm of y base b. So from here, the expanded form, we are going to express this one as a single form. Having said that, logarithm of 5x plus 4 minus logarithm of x is equal to logarithm of quantity 5x plus 4 all over x. So that is our examples number 1 and 2. Okay, so let's do have the last example. So same instruction, express the following as a single logarithm. So what we're going to do here is from the expanded form, we are going to express it in single form. So the last example is 1/2 logarithm of x plus 3 logarithm of quantity x minus 2. If we will try to analyze the given in example number 3, there is a number before the logarithmic term. There is a number before the logarithmic term. If we are going to analyze and we are going to correlate this one, to associate this one on the three particular laws in logarithm, is actually a result of the third law of logarithm, which is the power rule or the logarithm of a power, where it was given by logarithm of x raised to n base b. Every time that a number was raised to a given exponent and then it was related to a logarithm, the expanded form of that particular expression is the exponent multiplied to the logarithmic term. Okay? So if we will try to, but then in this case, from here, we will try to express it in its single form. Applying this one here, we will have 1/2 logarithm of x plus 3 logarithm of x minus 2 is equal to logarithm of x raised to 1 half. We just return 1 half to its exponential form. So logarithm of x raised to 1 half plus logarithm of x minus 2 quantity raised to the third power. Okay? But then we can express this one in logarithm of square root of x plus logarithm of x minus 2 quantity raised to the third power. Because we all know that any expression raised to a rational exponent, we can express that one in radical form. So from logarithm of x raised to 1 half, we just express x raised to 1 half in its radical form. Okay? Just only remember your grade 9 math. Okay? Changing from the exponential form to radical form or vice versa. But if we will try to check this one, the last expression that we had, we are actually adding two particular logarithms. The mere fact that we are adding two particular logarithms is actually a result of getting the product of two particular terms or expressions in logarithm. So if we will try to express this one again in its full single form, we are going to use the first law of logarithm, which states there that the logarithm of xy base b is equal to logarithm of x base b plus logarithm of y base b. So from here, we are going to express this one in its single form. In that case, we will have 1 half logarithm of x plus 3 logarithm of x minus 2 that is now equal to logarithm of square root of x quantity x minus 2 raised to the third power. So those are, from the first example up to this current example, those are the examples in expressing logarithms from the single form in expanded form or vice versa. So again, I am Mr. Jonathan Piroman, a Mathematics A teacher from Eli Barangka Integrated School.